All right, so after a long time of telling you have to memorize all of these formulas, IB finally put them in there. So it's actually, they use a whole page for this, but there it is, right? Notice that in this case, in all cases, R is the radius of this, right? So this is what the area of a circle, right? This is the circumference, the length of the line, right? And then this is the surface area of a sphere, right? So if you imagined a sphere, just if I can draw a sphere, right? Okay, that's the area of it. Notice that, interestingly, I think that's interesting, that it's just 4 times the frontal area, right? This becomes sort of interesting, right? Because the sun is here, right? The earth is here. The earth is actually a sphere, right? But from the sun, the earth looks like a circle. And so the earth absorbs pi r squared worth of area of the solar flux, but that's spread out over 4 pi r squared of the area of the earth, right? And then this is the volume of a sphere, and we use this all the time in fluid mechanics, et cetera, right? So in the B section here, I'll just find the formula. And so, for example, the buoyant force is rho v of the fluid, rho of the fluid times g, right? That volume, that's the volume. And if it is a sphere it's under the water, it could be 4/3 pi r to the third, right? Okay. Surface area of a sphere, we also use that in the equations that have to do with waves. Okay, things are find those. The wave equations, they've got wave characteristics. So this is 4.3.2. Okay, 4.3.2 is that the intensity in the watts per square meter is proportional to x to the minus 2, right? And that's because of this, right? If we've got a star here, and then we're out at some distance, right? You can imagine a giant sphere of area, right? And so that intensity, the power that the star is putting out, the watts of power that it's putting out, are spread out over 4 pi r squared of area. Okay, so we use that quite a bit, right? We also use it, the brightness of a star is the luminosity, or the watts, over 4 pi r squared, right, like that. Yeah. So oftentimes we'll use that Boltzmann's equation, which is that the power output is emissivity times sigma times area times temperature to the fourth. So that could be for the sun, right? The power being put out by the sun, and then we spread that out over the area that it's radiating from is 4 pi r squared, and then of course it could radiate out over another area. Okay, so we'll use that for that. I'm trying to think of when we use circumference. So circumference in orbit problems, velocity is 2 pi r over period, right? Circumference divided by period. So you might use it for that, right? If you're going in a circle, if something's going in a circle at a uniform speed, right? And then pi r squared, we use those in those formulas, like in continuity, and a lot of things, like pressure is force over area, right? That could be the area if it's a circular area, or you could have a pipe that is wide and then it narrows out, right? And this area could be a pi r squared, and this area here could be a pi r squared, right? Anyway, there you go. Probably didn't need all that information, did you?